Okay, so now what we're going to look at is pulling everything together from this unit. Pulling together the ideas you just saw in the last video of those 4 basic shapes of graphs, combined with everything we did earlier on, analyzing the first derivative to figure out where things are increasing and decreasing in maxes and mins, analyzing the second derivative to figure out concavity and points of inflection, and we're going to put all that together to be able to take a formula for a function and get a decent sketch of it. Today we're going to focus mostly on polynomials, and we'll look at some more complicated examples next class. I have 2 examples we're going to take a look at. And for our first one, we're going to sketch the function f of x equals x to the third minus 6x squared plus 9x. Now, to get us started with this, if it's easy to find the x-intercepts and the y-intercepts, I'm going to find them just because they're additional points that my graph is going to go through. If it's not easy to find them, I'm not going to bother. But in this one, they will be easy enough. I'm going to start by finding my x and y-intercepts. The x-intercept is in the form 0, no it's not, it's in the form x comma 0. And the y-intercept is in the form 0 comma y. To find the x-intercept, I'll plug in 0 for y, or for f of x. And I think you can go factor this and find what x is, and you're going to send that answer into Edpuzzle, and when you do that, I want you to give me coordinates for the x-intercept. You know the y-coordinate's 0. Go give me coordinates of the x-intercepts. Equals x times x minus 3 squared. Looks like x is going to equal 0 and 3, which means my x-intercepts are going to be 3 comma 0 and 0 comma 0. And really, these will just be some additional points my graph's going to have to go through. As for the y-intercept, this one's easier. I plug in 0 for x. I'm going to get 0 out of that. And actually, if 0 comma 0 is an x-intercept, it also has to be a y-intercept. And we've got that. If this is not an easy equation to solve, can't be factored easily or whatever, don't bother, we just won't include the x-intercepts. Next, we're going to move on and do all of our first derivative analysis. Which means you need to go find the first derivative, you need to go make a number line, figure out where the first derivative is positive, where the first derivative is negative, where we're increasing and decreasing, have maxes, mins, all that stuff. You go find your first derivative, I'll make the video pause, and test your number line, and get coordinates of the relative extrema. See what you can do with that. So f prime of x I'll factor out a 3. 3 times x squared minus 4x plus 3. I'm going to keep factoring. I'm going to get 3 times x minus 3, x minus 1. And looks like I have critical values at x equals 3 and x equals 1. I'm going to go make a number line and test make those my tick marks. 1, 3, this is f prime. Remember, you're going to make sure you're labeling this, especially since by the time we're done, we will have 3 number lines for each problem. And it's going to be a pain to keep track of them if we're not labeling them. I'm going to test by plugging into f prime, so plug in 4, positive, 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 that region's positive. Plug in 2, positive, negative, positive, positive times a positive is a negative. Plug in 0, positive, times a negative will give us a positive there. Increasing, decreasing, increase, and I'm not going to make you write out we're increasing between negative infinity to 1 and all that stuff. I think the number line will be good enough for these curve sketching problems. You'll have plenty of work in and of itself just to put all this stuff together. I see a relative max at 1 comma something, and then there's a relative min at 3 comma something. Remember that you find those y coordinates by plugging back into the original function. I'm going to plug into f. Zoom out so we can see a little more all at the same time. I'm going to go find f of 1. I'm going to get 1 cubed minus 6 times 1 squared plus 9 times 1. 1 minus 6 is negative 5, plus 9, I believe, is 4. 3 comma, well, f of 3, actually I already know that one, because 3 comma 0 was an x-intercept. It's also going to be the relative min, and if you're not believing that, 3 cubed minus 6 times 3 squared plus 9 times 3, 27, minus 54 plus 27. Yep, it's going to give us that 0 we wanted. More with this later. Now, I'd like you to go do a similar analysis with your second derivative. Go find the second derivative and your possible points of inflection, make your number line, test your regions, and see what happens with all that. Looks like there is a possible point of inflection at x equals 2. So x equals 2 is going to go over there. I'm going to test my regions, plugging into my second derivative this time. Plug in 3, it's positive. Plug in 1, it's negative. Concave up, concave down. Yep, there, oops, I shouldn't have labeled that f prime, that's f double prime. There is a point of inflection at 2 comma, find the y-coordinate by plugging into the original. F of 2 is going to give us 2 cubed minus 6 times 2 squared plus 9 times 2. That is 8 minus, do remember this is all without a calculator, otherwise there's kind of no point to doing this curve sketching stuff. 26 minus 24 is 2, point of inflection at 2 comma 2. Now I need to put all this stuff together and make a graph. And that's what we looked at on that sheet that we just did with the 4 basic shapes. Let's see what we can do here. I'm going to set up some axes. I'm going to fill in the points that I calculated. So for example, I know 3 comma 0 and 0 comma 0 are intercepts. I have a relative max at 1 comma 4, relative min at 3 0, already have that one, and a point of inflection at 2 comma 2. And what I'm now going to do is make my 3 number lines underneath my grid. F, F prime, F double prime. And I'm just going to copy these over from the work that I already did. My F prime number line has a tick mark at 1 and a tick mark at 3. Positive, negative, positive, increasing, decreasing, increasing. F double prime has a tick mark at 2, negative, positive, concave down, concave up. My top number line will have tick marks at 1 and 2 and 3. Take a moment, see if you can fill in the shapes, similar to what we did on that last worksheet. Concave down increasing will look like that. Concave down decreasing like that. Concave up decreasing like that. Concave up increasing like that. Now we're going to put this all together. Need to be concave down increasing until I get to 1 comma 4. So I'm going to look something like that and just pass through the x-intercept. Concave down decreasing like this. Concave up decreasing like this. Concave up increasing. I've got my graph. Yes, there's a lot that goes into these problems. This is why you're not going to have like 20 of these for homework, and not many on the test either, because I know there's a lot that goes into these. The video will pause if you need another moment to finish copying things down. And then we're going to go on, and we're going to take a look at one more. We're going to sketch the function f of x equals x times x minus 4 cubed, factored form polynomial function. I think you can probably find the intercepts pretty easily, so please go do that and send them into Edpuzzle. Remember, send them in as coordinates. since it's already factored, I've got x-intercepts at x equals 0, x equals 4, so I've got 0, 0, and I've got 4, 0. And again, if 0, 0 is an x-intercept, it's also going to be your y-intercept. I've got 2 intercepts over there. Our first derivative work. What you're going to have to do with this first derivative is use the product rule. And within the product rule, when you do the derivative of the second, you're going to need chain rule. This is going to become one of those problems where we do product rule, chain rule within it and all that, and then we have to do some factoring. I want to see how far you can get with the first derivative, so see what you can do. If you give up or whatever, just push continue, and I'll start doing my work. But I think you can probably handle some of this. F prime of x is going to equal first x times derivative of the second, 3 times x minus 4 to the second, times 1, plus second x minus 4 to the third, times derivative of the first, times 1. Okay, f prime of x is going to equal 3x times x minus 4 squared plus x minus 4 cubed. My GCF that I can pull out is an x minus 4 squared. So I'm left with a 3x and then an x minus 4 to the first. I'm going to go combine like terms here. X minus 4 squared. That's 4x minus 4. And you know what? My life's actually going to be a little bit easier if I could factor out the GCF over here. So I'm going to go and take out a 4. And I'm going to get 4 times x minus 4 squared times x minus 1. I'm going to make my number line. Tick mark at 1, tick mark at 4. This is f prime. Plug in 5. You know what? I don't even care about this. This is always positive, so really this is the only factor that will affect my sign. Plug in 5, it's positive, increasing there. Plug in 2, that's positive. This is always positive, so it's increasing there. Plug in 0, this is always positive. This is going to be negative, so I'm decreasing there. Decreasing, increasing, increasing. There's a relative min at 1, comma. Whatever I get when I plug into the original, that's going to be 1 times 1 minus 4 cubed. That's 1 times negative 3 cubed. That's going to be negative 27. We're now going to go deal with the second derivative work. When you do that, I think you should leave that 4 out front and use product rule and chain rule on your x minus 4 squared times x minus 1. Again, I want to see how far you can get. If you get stuck, just push continue, and I'll start doing my work. F double prime of x equals, I'm going to leave my 4 out front. First, x minus 4 squared times derivative of the second is times 1, plus second, x minus 1 times derivative of the first is 2 times x minus 4. I'm going to clean this up. 4 times, okay, x minus 4 squared plus 2 times x minus 1 times x minus 4. I think I can factor out an x minus 4. I'm left with an x minus 4 plus 2 times x minus 1. Distribute and combine like terms. Let's see here. F double prime of x is going to equal 4 times x minus 4 times 3x minus 6. You know what? I'm going to factor out a GCF again. I'm going to take out a 3 from those, which will give me 4 times 3, or 12 out front, times x minus 4 times x minus 2. Possible POIs at x equals 2 and x equals 4. There's my F double prime number line. 2, 4. Test your regions. Plug in 5. Positive, 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 all positive, concave up. Plug in 3. Positive, negative, positive, concave down. Plug in 1. Positive, negative, negative, becomes positive, concave up. Point of inflection at 2 comma something and 4 comma something. Remember that something's coming from plugging into the original function, so f of 2 is 2 times 2 minus 4 cubed. That's 2 times negative 2 cubed is negative 8. That's 2 comma negative 16. 4 comma, I already know that one because it was an x-intercept, 4 comma 0. See if you can put this all together and sketch your graph. Now we're going to go and we're going to do our graph. I need my 3 number lines. F prime, F double prime. My tick marks, 1, 2, 3, 4, 5. But I think on the y-axis I'm going to count by tens, so I'm going to go 10, 20, 30, negative 10, negative 20, negative 30. F prime, I need a tick mark at 1 and another tick mark at 4. Negative, positive, positive, decreasing, increasing, increasing. Second derivative, I need tick marks at 2 and 4. Positive, negative, positive, concave up, down, up. 1, 2, 4. I need one of these. I then need one of these, which then becomes one of these, which then becomes one of these. I need to get some points on my graph. Point at 0, 0, 4, 0. Let's see, min at 1 comma negative 27, about there. Point of inflection at 2 comma negative 16, maybe about there. I need one of these things until I get to x equals 1, kinda, sorta like that. Then I'll curve around, I'll look like that. Curve around, take on this shape. Curve around, and do one of those. And these are the easier graphs compared to what we're going to look at in the next video. In addition to doing some homework on this, you're also going to do a short reading just to remind you how to find asymptotes, because the graphs that we look at next time will have asymptotes on them. So that'll be fun. More with that, though, next class.